Let's do some advanced factoring involving exponentials. We'll start by factoring e to the 2x plus e to the x minus 12. And what we want to recognize is that this is in what we call quadratic form, and it's easier to recognize if we rewrite it. I'm going to rewrite the first term as e to the x as a quantity squared. Then we have plus e to the x minus 12. Now you may already now recognize it to be in quadratic form, but it's even easier to recognize it if we perform a substitution. We're going to let a different variable, I'll say y, equal e to the x. Now I'm going to replace each e to the x with the variable y. So I have y squared plus y minus 12 now, which we can more clearly see is a quadratic, and a nice one with a leading coefficient of 1, so it's pretty easy to factor. We're going to go ahead and factor it. So we're going to have y and y as the first part of each factor, two numbers to multiply to give us negative 12, but add together to give us positive 1 are going to be positive 4 and negative 3. So we're not done yet because we do have to return back to our exponential. So we're going to replace y back with e to the x. And that's going to leave us with e to the x plus 4 as one factor and e to the x minus 3 as the second factor. Let's do another example. Let's go ahead and factor e to the 4x minus 4e to the 2x. This only has two terms, so we should look for the greatest common factor. Well, both of these have in common an e to the 2x. So if I factor out an e to the 2x, then what I'm left with in the first term, I would subtract 2x from 4x, leaving me with an e to the 2x. And then in the second term, if I factor out e to the 2x, I'm just left with minus 4. So we have factored out a greatest common factor, but what I'm left with is something that can be factored further. This is actually a difference of squares. I'm going to rewrite it so that I can see it more clearly. So e to the 2x is e to the x, quantity squared, and 4 is 2 squared. So I'm not going to do a substitution this time. I'm going to go ahead and simply apply what I know about the difference of squares. That if I have something squared minus something squared, it's going to factor to that first thing, e to the x, and then minus the second thing, so e to the x minus 2, and then those same terms but added together, e to the x plus 2. And now it can't be factored any further. So we have our factorization. Before we move on to the next example, I want us to just take a moment to think about something important that we did here. So we said that between e to the 4x and e to the 2x, we would factor out an e to the 2x. So between those two exponents, 2x is smaller than 4x. So that is how we made that decision to factor out a 2x. And when we did that, ultimately, it was subtracting 2x from 4x. If we take something out in terms of the exponent, we're subtracting that from the exponent. So I just want us to keep that in mind as we head into the next example. Let's go ahead and look at this next one, 6e to the negative x minus 4e to the 2x. So what are we going to factor out? Well, there's two terms. We'll think about looking at each term and focus on the coefficients first. So between 6 and negative 4, what we can factor out is a positive 2. So we can evenly divide 2 into 6 and 2 into negative 4. So we're going to factor out a positive 2. Now, we could technically factor out a negative 2, but it's traditional to leave the first term positive. So we're going to go ahead and stick with factoring out just a 2. And now let's look at the exponential pieces, e to the negative x and e to the 2x. What are we going to factor out there? Like I had mentioned from the last example, between 4x and 2x, when those were the exponents, we pulled out 2x because it was smaller. Well, negative x is negative. It's smaller than positive 2x. So we are going to take out e to the negative x. We're going to factor that out. So what's going to be left over? Now, if I factor out the 2, I'm going to have a 3 left over from 6. And then if I take out all of e to the negative x, that's gone. All I have left is 3. Then I'm going to have minus 2. So if I take out 2 from negative 4, I'm going to have negative 2 left. But what's going to be left from here? So if I take out negative x, remember what we have to do is we have to subtract that quantity. So what's going to happen is I'm going to have e to the 2x minus negative x. So when I have minus a negative, that becomes plus x. So this is actually going to end up being a 3x. So what we're going to have is 2e to the negative x times the quantity 3 minus 2e to the 3x. And if I think about distributing this back in, it's going to work out. So 2e to the negative x times 3, that's 6e to the negative x. And then 2e to the negative x times negative 2e to the 3x. 2 times negative 2 is negative 4. And when you multiply e to the negative x and e to the 3x, we would add those exponents. When you multiply, and they have the same base, you add the exponents together, and that takes us back to that 2x. So we did, in fact, factor out correctly 2e to the negative x. Now, technically, you can factor sort of anything out of anything, but the traditional thing to do is, between the coefficients, like I said, is to pull out the value that keeps that first term positive. Could have pulled out a negative 2. And when we factor out values raised to exponents, we traditionally factor out the smaller of the two exponents. That's what's going to make things nicer as we move towards solving equations that kind of look like this. So I'm going to go ahead and box this in, but while also reminding you that because we have a negative exponent, you might see the answer with that e to the negative x in the denominator so that it has a positive exponent. So we have to leave the 2 times the quantity 3 minus 2e to the 3x all over e to the positive x, because we prefer positive exponents rather than negative exponents.